for example 2, we're going to solve the equation by factoring. We are not working with a function like we did in example 1. However, when we do work with quadratic functions, and we solve quadratic functions, we are going to have to use the methods that you do when you solve quadratic equations. So there's no f of x, we're not letting y equal 0, we're just revisiting and refreshing the methods that you've learned previously for solving quadratic equations. Standard form for a quadratic equation is up top here in this box, and you can see you have an ax squared term, a bx, and a c term. And if you have all three of those terms, then you're going to try to solve by factoring. And if factoring wouldn't work, then you can go ahead and try something else, like maybe the quadratic formula or completing the square. I happen to know that factoring works on this problem because I chose it so that we could practice solving by factoring. And the first thing that you need to do when you solve a quadratic equation by factoring is you need to move everything to one side and set your equation equal to 0. So I'm going to go ahead and I'm going to move over that 3x. So you get 2x cubed minus x squared minus 3x equal to 0. And then it doesn't look quadratic yet, but it will in a second. I see that each one of my terms has a greatest common factor, and whenever you are solving by factoring, you want to check for a GCF first. So each one of these terms has an x. I'm going to take it out, and I'm left with 2x squared minus x minus 3 on the inside, and now I have my quadratic. And when you have a trinomial, you're going to try to factor that into two binomials. And so I'm going to get a set of parentheses for each binomial. And I don't want to get into a long-winded discussion on how you factor a trinomial because it's going to make the example super long. But if you're having any issues with that, you can certainly ask me, or you can look up factoring on how you factor a trinomial. Okay, so factors of 2x squared need to go in first position of each binomial, and factors of 2x squared are 2x times x, and factors of the last term, negative 3, are going to go in last position of each binomial. So then I'm going to put the only factors of 3, which are 3 and 1. And then you need to make sure that if you were to refoil this back out, you would get back what you started. And I already know my f in FOIL is going to give me 2x squared, and I know my l in FOIL is going to give me 3 here on the end. I just need to make sure my inners and my outers combine back into a negative 1x above. So my inners in FOIL give me a 3x, and my outers in FOIL, when I multiply them, give me 2x. And if I make this a minus 3, I get negative 3x. And if I make this a positive 1, I get positive 2x. And these two do indeed combine to give me negative 1x on top. So that's how I know it's the correct factorization. If I didn't get these two terms, my inners and my outers, to combine to negative 1x, then I know that they're probably not in the right order, and then I would switch my 3 and my 1. And once again, that's a pretty basic, quick explanation on how you factor a trinomial, but I just don't want to spend a whole lot of time doing that on this example because it's just going to take a long time. So that's our correct factorization. And then you're going to take, for the last step, each factor and set each factor separately equal to 0 and make 3 little mini equations up. So my first factor is x, and I set that equal to 0. My second factor is 2x minus 3, and I set that equal to 0. And then I have x plus 1, and I'm also going to set that factor equal to 0. And then I go ahead and solve my mini equations. X equals 0, nothing to solve there, it's already done. Second equation, you must add 3 and divide by 2, and you get 3 halves. And then here I'm going to subtract 1, and that's my last solution. So these guys are not zeros. You didn't let y equals 0. You didn't have a function that you could graph. You don't have a whole entire curve that can be drawn. You get 3 little answers that satisfy the equation that if you would plug those numbers back in, you would make a true statement. Now, that being said, you can use a graphing calculator to actually solve for those solutions. We're going to fake out our graphing calculator and pretend that we actually have a function when we really don't. And I did want to say this, and I forgot to mention it. If I were to graph my solutions, they would just be graphed on a number line, and that's it. You wouldn't have a whole coordinate plane. I could graph my -1 would come first, and you'd put a little dot on your number line, and then I would have 0 and a little dot on the number line, and then finally the last little dot on my number line would be at 3/2 or 1.5, and that's what you get. No big curve, no function, no coordinate plane, 3 little solutions that if I plug back into my problem would satisfy that equation and make a true statement. Okay, so over here we're going to fake out our graphing calculator and we are going to pretend that we have a function. So we're going to move everything to one side, just like we did when we solved by factoring. And we are going to pretend that this 0 over here on the right side was where you would have let y equals 0 if there was a y. And then we're going to put all of this stuff into our graphing calculator and just pretend that it actually was a function when really it's not. So in for my y equals, I'm going to type in 2x cubed minus x squared minus 3x, and I'm going to hit graph. Now I'm already zoomed in to my graphing calculator, but you might have been just zoomed in from the window. Here's what it looks like zoom standard. If you are zoomed standard, then you might not be able to find your zeros very easily. I think my graphing calculator just locked up. So let's turn it back on, y equal graph, and see if it actually draws it this time. There it is. So you can see that that's not zoomed in very well, and it's going to be hard for me to find my zeros on my graphing calculator. So I would just hit zoom, then zoom in, enter to actually zoom in, and then you get that nice window where you can see everything very clearly. And then even though I have an equation and it's not a function, my graphing calculator doesn't know that. And all of these zeros that you see on this graph, these x-intercepts, they're actually the solutions that I found by hand over here on the left side when I did the problem by hand. And you're just going to go ahead and hit second, trace, 0, even though we really don't have zeros. My graphing calculator has no clue that I really don't have a function, and so we're just going to pretend that we're finding a 0. So left bounds on the left of that 0, you set it by hitting enter, then move your cursor to the right a little bit, and above that 0 is going to be my right bound, set it with enter, and then go ahead back on top, and then hit enter again, and there you have it. -1 is one of my answers right here. And let's find another one. Second calc, 0, even though we're kind of not telling our calculator the truth. That would be the left side of that 0. Hit enter. Right bound would be a little to the right there. Hit enter. The actual guess on the 0 itself is going to be right there. And enter, and there you have it. There's our second x solution right here. X is equal to 0. And then we would expect the other one to be at 3/2 or 1.5. Hit second, calc, 0. I'm going to move over. And I guess I could just hold this down. I don't really need to tap, 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 tap. Okay, so there's your left bound. And then I'm going to set it about there. Right bound. Enter. Guess on top of that 0 as close as I can get. And there we have it, 1.5, which is 3/2. And it gave me my final answer right there. So even though we really don't have a function, your graphing calculator doesn't know that. If you treat your equation as though it was a function, you move everything to one side, set it equal to 0, and you pretend that you actually let y equal 0, you can use your graphing calculator to solve this.